Hello everyone. Today we will discuss about agent and strong method problem solving. Agents. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. Operates in an environment, perceives its environment through sensors, acts upon its environment through actuators or effectors. Types of AI agents: Simple reflex agent, model based reflex agent, goal based agent, utility based agent, learning agent. Simple reflex agent choose actions only based on the current percept, rational only if a correct decision is made only on the basis of current percept. Their environment is completely observable. The simple reflex agent works on condition action rule, which means it maps the current state to action. Model based reflex agent, a model of the world to choose their actions. They maintain an internal state. Model, knowledge about how the things happen in the world. Internal state, it is a representation of unobserved aspects of current state depending on percept history. Updating the agent state requires information about how the world evolves, how the agent's action affects the world. Goal based agent, they choose an action so that they can achieve the goal. Goal based approach is more flexible than reflex agent since the knowledge supporting a decision is explicitly modeled, thereby allowing for modifications. Goal, it is the description of desirable situations. Utility based agent, they choose actions based on a preference for each state. There are conflicting goals out of which only few can be achieved. Goals have some uncertainty of being achieved, and you need to weigh likelihood of success against the importance of a goal. Learning agent. A learning agent in AI is the type of agent that can learn from its past experiences or it has learning capabilities. It starts to act with basic knowledge and then is able to act and adapt automatically through learning. A learning agent has mainly four conceptual components, which are: learning element. It is responsible for making improvements by learning from the environment. Critic. Learning element takes feedback from critics, which describes that how well the agent is doing with respect to a fixed performance standard. Performance element. It is responsible for selecting external action. Problem generator. This component is responsible for suggesting actions that will lead to new and informative experiences. Strong method problem solving. Human experts are able to perform at a high level because they know a lot about their areas of expertise. This fact is the basis for design of strong method problem solvers. Strong method problem solvers are knowledge intensive systems as they require extensive knowledge of the problem domain to solve problems. These systems are also called knowledge based problem solvers. Strong method problem solving, expert system technology, rule based expert systems, model based, case based, and hybrid systems, planning. Expert systems. An expert system is knowledge based system. Expert system uses knowledge specific to a problem domain to provide expert quality performance in that application area. Expert system designers acquire this knowledge from the human experts of the problem domain. A human expert of the domain will not accept advice from a computing machine without understanding the justifications for it. Therefore, an expert system should support inspection of the reasoning process, providing information about the state of problem solving, explanation of the choices and decisions the program is making. An expert system should allow modification of the knowledge base, in that the system should allow adding and deleting skills from the knowledge base, as the modification of a single rule should have no global syntactic side effect. Rules may be added or removed without requiring further changes to the program. Expert system to use heuristic problem solving methods. Expert systems are built to solve a wide range of problems in domains such as medicine, mathematics, engineering, chemistry, geology, computer science, business, law, defense, education. Rule-based expert systems. The architecture of rule-based expert systems may be understood in terms of the production system model for problem solving. If we regard the expert system architecture as a production system, the knowledge base is the set of production rules. Condition action pairs are represented as if then rules, with the premises of the rule if portion corresponding to condition, the conclusion then portion corresponding to action. When the condition is satisfied, the expert system takes the action of asserting the conclusion as true. Case-specific data are kept in the working memory. The inference engine implements the recognize act cycle of the production system. This control may be either data-driven or goal-driven. The breadth-first data-driven example begins with no information in working memory. In a goal-driven expert system, the goal expression is initially placed in working memory. The system matches rule conclusions with the goal, selecting one rule and placing its premises in the working memory. This corresponds to a decomposition of the problem's goal into simpler sub-goals. The process continues in the next iteration of the production system, with these premises becoming the new goals to match against the rule conclusions. The system thus works back from the original goal until all the sub-goals in working memory are known to be true, indicating that the hypothesis has been verified. In an expert system, sub-goals are often solved by asking the user for information. Most expert system shells allow the system designer to specify which sub-goals may be solved by asking the user. In some of the design inference engines may ask the user about sub-goals that fail to match the conclusion of some rule in the knowledge base. That is, if the program cannot infer the truth of a sub-goal, it may ask the user. Model-based reasoning. Model-based system is based on a model of the structure and behavior of the device that the system is designed to simulate, used for well-structured problems, not for stock pricing or modeling, not well-structured engineering problems. Example, diagnosing hardware or a machine, automobile diagnostics. Based on written documentation, the problem is extracting knowledge. Observed behavior is combined with predicted behavior. The difference between them is called a discrepancy, indicating a defect, then a process initiated to diagnose the nature and location of the defect. Case-based reasoning. Collection of a set of cases. Store a case in the case base. Case-based reasoning on human information processing. Modeling some problem areas. Thinking about how human processes information. Try to remember previous case or recall similar cases and modify to fit a new situation. Examples: law, diagnosis, strategic planning. Human experts depend heavily on past experiences when solving new problems. A case-based reasoning emulates this HIP model and maintains a historical case. It retrieves cases relevant to the present problem situation from the case base and decides on the solution to the current problem on the basis of the outcomes from previous cases. Hybrid systems. A hybrid intelligent system is one that combines at least two intelligent technologies. For example, combining a neural network with a fuzzy system results in a hybrid neuro-fuzzy system. The combination of probabilistic reasoning, fuzzy logic, neural networks, evolutionary computation forms the core of soft computing. Planning. Planning is required for every task. For example, reaching a particular destination requires planning. To reach a particular destination, first we should find the best route and then identify a set of actions to be done at a particular time is called as planning. Planning is nothing but deciding a set of actions to be performed in agent environment based on the perception to achieve the decided goal. Thank you.